All right, here is the video for subtracting rational expressions. All right, for the first example, we're going to do x minus 3y over 18x minus x minus 6y also over 18x. So just like we did before, we have a common denominator, so we're going to go ahead and write this problem over that common denominator. And the thing we need to be careful about today is to make sure that we distribute the negative for this subtraction problem. All right, so I would say it's not even a bad idea to go get a separate color to make sure that you are distributing that negative every time, because if you're going to make a mistake today, that's the mistake that you're going to make. So I'm going to go ahead and just copy down the terms from that first fraction, x minus 3y. That part's going to be easy, no mistakes there. And then I have a negative x minus negative 6y, minus minus makes a plus, so I'm going to say plus 6y. That's the most likely part to make a mistake on, is that second term. So minus a negative makes a plus, minus minus plus 6y. All right, so now I can go ahead and combine my like terms. X and negative x, those are going to cancel out. And so I've got a negative 3y and a positive 6y. That gives me 3y over 18x. The 3 and the 18 can go ahead and reduce. 3 divided by 3, 18 divided by 3, and I'm going to end up getting 1y divided by 6x is my answer. All right, for the next example, we have 8n divided by 24n squared m minus 3m plus 2n over 24n squared m. All right, so the common denominator, 24n squared m. All right, I'm going to make sure that I distribute that negative. So I'm going to copy down what I had on my first fraction, just that 8n. And then I'm subtracting 3m. I'm subtracting 2n. All right, and now that I've distributed my negative, I can go ahead and combine like terms. So 8n and negative 2n is 6n, and then negative 3m. Now, if I look on the top, I can see that between the 6 and the 3, I have a GCF of 3, so I can go ahead and take that out in hopes that it will simplify with the denominator. 2n minus m, and it's going to, because 3 and 24 are going to reduce a little bit. So 3 divided by 3, 24 divided by 3. So 3 divided by 3 is 1. Those are just going to straight up cancel. 2n minus m. 24 divided by 3 is 8. N squared m. Final answer. Okay. So those are kind of what the problems are going to look like if you have a monomial on the bottom. I know you guys kind of gave me some feedback on the adding fractions. You didn't really like these problems because they had two variables in the problem, so we'll probably like these other examples better. All right, so if we have 2x minus 3 over 4x plus 16, one variable, so much nicer. Negative 2x plus 1 over 4x plus 16. So we've got that one denominator, 4x plus 16, common denominator already. I'm going to make sure that when I do this problem, I distribute that negative. Always really careful about that. So we've got 2x minus 3, just copying down that first one. Subtract a negative 2x, that makes a plus 2x, and then minus 1. All right, so I'm going to combine my like terms. I've got 2x and 2x, that gives me 4x. Negative 3 and negative 1 gives me negative 4. So really the only part that makes this different from adding our fractions is this part right here. We just got to be careful right here, and then from there, just combining your like terms and making sure you do your factoring correctly. So we have a binomial over a binomial. This is just some GCF factoring. Between 4x and minus 4, we have a GCF of 4. X minus 1 left over. In the denominator, 4x and 16, we have a GCF of 4. X plus 4 is left over. The 4's will cancel. And we end up getting x minus 1 over x plus 4. All right, one last example problem for this video. 4a plus 11 divided by 6a squared plus 18a minus a plus 2 over 6a squared plus 18a. So we have that common denominator, 6a squared plus 18a. We're going to make sure to distribute that negative. So I've got 4a plus 11, subtract the a, subtract the 2. So 4a and negative a is 3a. 11 and negative 2 is positive 9. 6a squared plus 18a. So again, I have a binomial over a binomial. That means that I'm going to be doing GCF factoring. So between the 3 and the 9, I have a GCF of 3. That leaves me with a plus 3. In the denominator between 6 and 18, I have a GCF of 6. Between a squared and a, I also have a GCF of a. And that leaves me with a plus 3. All right, so here, the parentheses are identical. Those can reduce. We can completely cancel those. The 3 and the 6 are not identical, but they can at least be reduced. We can divide both of those by 3. 6 divided by 3. Okay, so 3 divided by 3, we're going to leave a 1 behind. Everything on the top has completely disappeared, so we leave a 1 there. 6 divided by 3 is 2, so we have a 2 left over and an a. So 1 over 2a is our final answer. And that is how we subtract rational expressions. So I would recommend, at least for the first day that you do this, to have a marker out just as a physical reminder to make sure you distribute that negative. If you're going to make a mistake today, it's going to be forgetting to distribute the negative. That is the common mistake that I see students make.